The shape of the Earth has been debated for centuries. However, modern science has irrefutably proven that the Earth is spherical. This assertion is supported by a wealth of evidence, ranging from ancient astronomical observations to the stunning photographs of Earth taken from space. Today, with advancements in technology, we have the ability to observe the Earth's curvature in real time through satellite images and high-definition videos. But despite the overwhelming evidence, some people still adhere to the flat Earth theory, even though it contradicts centuries of scientific research and basic physical principles. Flat Earth proponents have constructed elaborate myths to explain away the wealth of evidence supporting a round Earth. However, these explanations often conflict with the fundamental laws of physics and our understanding of the universe. For example, the phenomenon of gravity is perfectly consistent with a spherical Earth. Gravity pulls objects toward the center of mass, and this process works exactly as we would expect on a spherical planet. On a flat Earth, the gravitational forces would behave differently, causing various anomalies that we do not observe. The motion of celestial bodies also supports the round Earth model. The planets in our solar system, including Earth, follow elliptical orbits due to the gravitational forces of the Sun. Observing the movement of stars and planets across the night sky further confirms that Earth is a rotating sphere. If the Earth were flat, we would not observe the same predictable patterns in the night sky, and the behavior of stars and planets would be vastly different. One of the most compelling pieces of evidence comes from the phenomenon of eclipses. A lunar eclipse occurs when the Earth passes between the Sun and the Moon, casting a shadow on the Moon's surface. The shadow we see on the Moon is always round, a fact that would be impossible to explain if the Earth were flat. The round shadow cast on the Moon during every lunar eclipse is a direct result of Earth's spherical shape. The science of time zones also relies on the Earth's spherical nature. If Earth were flat, we would not experience the gradual progression of time that we observe as we travel across long distances. The curvature of the Earth is responsible for the way daylight shifts across the planet, creating different time zones. If the Earth were flat, we would experience constant sunlight or darkness across the entire surface, making the concept of time zones nonsensical. Furthermore, the development of space travel has provided irrefutable evidence that Earth is a sphere. Astronauts aboard the International Space Station, ISS, regularly observe and capture images of Earth's curvature. They can see the planet from various angles, proving its round shape. The idea of a flat Earth fails to account for the billions of dollars spent on space exploration and the thousands of scientists, engineers, and astronauts who have contributed to our understanding of the Earth and space. The sheer logistics of creating and maintaining such a global deception would be impossible to manage, especially given the complexity of modern space missions. One of the core principles of science is to explain observed phenomena in the simplest and most consistent way possible. The spherical shape of the Earth perfectly adheres to this principle, as it allows us to explain a wide variety of scientific observations in a single, unified framework. The theory of a flat Earth, on the other hand, requires a vast network of convoluted and often contradictory explanations, none of which are supported by empirical evidence. In contrast to the flat Earth theory, which relies on ad hoc explanations, those that are created specifically to defend a particular belief, scientific theories are built on the foundation of testable hypotheses and empirical data. The Earth's roundness is not only supported by astronomical observations, but also by physical evidence, such as the way ships disappear over the horizon, the way airplanes navigate using a curved Earth model, and even the way shadows are cast during the day. Another important observation is the Earth's atmosphere. Our atmosphere bends light, a phenomenon known as refraction. The curvature of the Earth plays a crucial role in how we see objects on the horizon. If the Earth were flat, we would observe different optical phenomena, like objects remaining visible at much greater distances than they do on a spherical planet. This is just another example of how the Earth's curvature influences our daily experiences in subtle but measurable ways. In the end, the shape of the Earth is one of the most well-established facts in science. It is a fundamental truth that has been proven through centuries of observation, experimentation, and technological advancement. Any theory that contradicts this truth is unsupported by science and relies on an outdated, flawed understanding of the natural world. The importance of education and access to reliable scientific sources cannot be overstated. As misinformation continues to spread, it is essential that we promote science-based education to combat these unfounded beliefs. We must continue to present the truth in an accessible and engaging way, helping people of all ages understand the world around them and the universe beyond. In conclusion, the shape of the Earth is not just a simple fact, it is a cornerstone of our understanding of the universe. As we explore the cosmos and push the boundaries of human knowledge, the Earth's roundness remains a constant reminder of the power of science, evidence, and critical thinking.